So today's notes are on using proportional relationships. Make sure you have the date on your paper, which is the 15th. Okay, so our one vocab word is indirect measurement. This is any method that uses formulas, similar figures, which we've been talking about for weeks, and or proportions, again, which we've been talking about for weeks. We're going to need this. To measure an object. So for instance, if we're standing next to a building, we can't directly measure the height of the building easily, right? We would need, I don't know, a really big ladder, a forklift, like things to help us measure the building. But we can use other things and indirectly get the height of the building. So that's what we're going to do. You guys are going to see my fabulous drawing skills today. Are you ready? Okay, well, here we go. Okay, Sid is 72 inches tall. To measure a flagpole, Sid stands near the flag. Sid's friend Miranda measures the lengths of Sid's shadow and the flagpole shadow. Sid's shadow is 48 inches and the flagpole shadow is 128 inches. Find the height of the flagpole. Okay, so first of all, we have Sid. Now see, Sid is 72 inches tall, right? What was the length of Sid's shadow? 48 inches. And where is his shadow located? On the ground. Okay, shadows are on the ground. So his shadow is 48 inches. Now I'm just going to complete this triangle. And it's a right triangle. Sid's standing straight up. He has a shadow that's 48 inches tall, or 48 inches long. Then we have a flagpole. And the flagpole, we don't know. That's what we want to find the height of. So I'm going to call that X. But I do know that the shadow of the flagpole is 128 inches. Again, that creates a 90-degree angle. A right triangle. So we're going to use indirect measurement, literally what we've been doing the last few weeks by writing a proportion to solve for the height of the flagpole. Here's how I like to compare things. So I like to do shadow over shadow equals height over height. So shadow to shadow, height to height. Now again, there are multiple ways to set this up as long as you're using the same pieces. But if you can just remember shadow to shadow, height to height, you'll be okay. So the first shadow is 48 inches. The second shadow is 128 inches. Sid's height is 72 inches. And we don't know the flagpole, but that's what we're going to find out. So shadow to shadow, height to height. Can you solve this proportion? Yeah. Okay, so let's cross multiply. So I get 48x equals 9,216 divided by 48. 192. We're going to leave it 192. 192 what? Inches. All of our units here were in inches. Because we're dealing with word problems, you need to have units now. Okay, all of these were inches. So we need to have inches. Does it make sense that the flagpole is taller than Sid? Yeah. So if you got a really small number for the flagpole and Sid's taller than the flagpole, you might want to go back and check your work. That doesn't make sense. Okay. Should you ever get any negative numbers here? No, why not? Not necessarily because it's supposed to be taller, but what are we talking about?
Going up, not down.
How tall something is, the height of something. If we're talking about height, there's not going to be any negative values, right? There is always a height to something. Are you okay with that one? Yeah. Okay, this is the fun one to draw. Here we go. A student wanted to find the height of a statue of a pineapple in Nambour, Australia. I don't know. She measured the pineapple's shadow and her own shadow. The student's height is 5 feet 4 inches and the student's shadow is 2 feet. The pineapple shadow is 8 feet 9 inches. What is the height of the pineapple? Okay, so let's just start by drawing. Shh, it's a good pineapple. I told you guys I'm not a good drawer.
Oh my God.
Yeah. And then we have a student. I'm going to make this student a girl this time. She's going to wear a skirt. Just a skirt.
That's definitely a dress code.
You don't really have to draw any of these pictures, but I think it's fun. Okay, I want you to fill in the information based on, I don't want you to set up anything, I just want you to fill in the information for the triangles based on the word problem. You guys do not have to copy my pictures either. I mean, if you want to, that's fine, but you don't have to. So fill in the information. I don't want you to solve anything. Don't solve anything yet. I just want you to fill it in because we need to look at something before we start solving.
This is kind of fun. This is something you actually might do in real life.
This, yeah. We'll go fly kites at some point and do this. 8 feet 9 inches. And this is X. Okay, so you should have your figures looking something like that. Does anyone see any problems? It's in feet and inches. We can't have that, which is why we converted in our warm-up. So we need to convert everything to inches to start off. So if I convert 5 feet 4 inches to inches, what do I get? 64, right? Because 5 times 12 is 60, plus the 4 is 64 inches. What about 2 feet? What does that convert to? 24 inches. And 8 feet 9 inches?
105.
105? Someone want to confirm that? Yeah? Okay. Now that everything is in the same unit, we can set up our proportion. So I want you to take a second and I want you to set up your proportion. Height to height, shadow to shadow. Or shadow to shadow, height to height. See if you can set up the proportion. Shadow to shadow, height to height. Did you get this proportion here? 24 over 105 equals 64 over x, or something similar. It's either completely upside down. Okay. So when we solve, we get 24x equals, I don't know. Thank you. Divided by 24. X equals 280 what? Inches. Okay, now we're not quite done. We need to convert it back. Hold on. Okay, so everyone okay at this point with 280 inches? Anyone know how I would convert it back to feet and inches? Samantha?
Divide it by 12, and then if you get a decimal, then you have to add back the inches to it.
Okay, so We're going to divide by 12, right? Because we multiplied by 12 to get inches, so we divide by 12 to convert back to feet. So here's what happens. I'm going to try to show you my calculator. And I'm going to tell you where people mess up, and you're going to listen to me because I'm full of great information, right? Okay, so 280 divided by 12 is 23.3. Here's what people do, and here's what is wrong. They say the answer is 23 feet, 3 inches. That is not correct. Okay, 23 feet is correct. So I'm going to write 23 feet. And here's the easiest way to do it. 23 times 12 gives me 276. What is the difference between 280 and 276? 4, which means there are 4 inches left over. If you give me 23 feet, 3 inches, you will get it wrong. Do you see what we did? No? Okay, one more time. So 280 divided by 12 was 23.3. So I'm not going to look at the decimal part. I'm just going to look at that 23 part. Okay, so 23 feet. Now I need to know how many inches that is so I can figure out what my difference is. So 23 times 12 was 276. Well, I had a total of 280. So 280 minus 276 gave me a difference of 4 inches. Okay, we'll practice this a few times. But it's a lot of multiplying by 12 and dividing by 12. Okay, but this is our final answer. So the pineapple in Australia is 23 feet, 4 inches. If we were talking about a normal pineapple, that wouldn't make sense, right? But we're talking about a statue. It gave you the context in the problem. We're talking about a statue in Australia. It's a huge statue.
Oh, I thought it was actually.
Cool? Okay. Why don't you try number 3? Take a second and try number 3. If you need to use your group, you can. See how we did. So we have a palm tree. Okay, well, it's close. And the tree's shadow is 7.2 meters. At the same time of the day, you measure a meter stick. So just a stick. That has a shadow of 1.6 meters. Find the height of the tree. Well, what's the height of the meter stick? Oh, good. Okay, the height of a meter stick is 1 meter. Do I need to do any conversions? No, because everything's in meters. It's okay that there's decimals. Everything's already in meters. So shadow to shadow, height to height. Shadow to shadow, height to height. So I'm getting 1.6x equals 7.2. Which means x is 4.5 meters. Okay, number 4 is the last one. You're going to have to do some conversion. So I want you to try it. Start to finish, set it up, convert, and then convert back to feet and inches. So take a second. If there's someone in your group who's solid on this, maybe you can help walk everybody through it. Here's what you should have for your 2 pictures. So far, so good? Okay. Then you need to convert. So 5 feet converts to 60 inches. 5 feet 6 inches converts to 66 inches. 14 feet 2 inches converts to how much? 170. 170 inches. Everyone still okay? Okay. So shadow to shadow, height to height. 60x equals 11,220 divided by 60 is 187 inches. Now, if you can only get that far, you're going to get most of your points. If you can't convert at the end, this will still get you most of your points, but you do want to practice converting. Okay, so you're going to take your 187 inches and divide by 12. You get 15.5. I don't care about that decimal part, but I'm going to use that 15. So 15 feet. Well, how many inches is 15 feet? So 15 times 12 gives me 180, which means there's 7 inches left over. Because 187 minus 180 is 7. Not too bad, hopefully. Questions, comments, concerns? Yes, ma'am. How'd I get 180? Oh, 15 times 12. So 15 times 12 is 180, and then 187 minus 180 is 7 inches. So I have to multiply by 12 again so I can figure out what the difference in inches is. Okay? Anything else? All right.